Have you ever wondered if the very space around you could one day simply end? Not with a bang, but with a strange, silent vanishing act, where the fabric of reality itself unravels, leaving nothing behind. It's a question that seems almost too big, too abstract to grasp, yet it sits at the heart of our understanding of the cosmos. Not by exploding, but by collapsing in on itself. Imagine everything you know, every star and galaxy, being drawn inward, as if the universe is folding up its own stage. Scientists have seriously considered this possibility, debating whether the universe's vast, dark expanse might have a final act, a closing curtain. They use powerful simulations and telescopes to search for clues, piecing together the ultimate fate of everything. We often think of space as a passive backdrop, but what if it's dynamic, capable of stretching, bending, and even failing? Space isn't just emptiness. It's an active participant in the cosmic drama, shaping and being shaped by everything within it. Imagine the universe not as an eternal stage, but as a temporary structure, born in a burst of energy and perhaps destined to collapse back into unimaginable density. The same laws that allowed it to expand could, in theory, reverse, causing everything to contract. If space itself collapses, there's nowhere for it to fall to. The arena itself shrinks, pulling everything with it. It's not just matter that disappears, but the very stage on which existence plays out. Every point in the universe would rush toward every other, not because we move faster, but because the space between vanishes. The distances that once separated galaxies would shrink to nothing, erasing the boundaries of the cosmos. This isn't about predicting doom, but about understanding reality and following physics to their ultimate conclusions. It's a journey into the deepest questions we can ask, driven by curiosity and the desire to know our place in the universe. The same science that lets us explore Mars also leads us to ask, what are the rules that govern space and how stable are they? Could the laws we trust to send robots to other worlds also hint at a cosmic finale? The story of a potential cosmic collapse is the story of the universe itself, from its fiery birth to its possible silent end. It's a reminder that even the grandest stages may one day close, and that our quest to understand the cosmos is as infinite as the universe we inhabit. To grasp how space could collapse, we must rethink what space is. It's not just an empty stage where the universe unfolds, but something far more dynamic and mysterious. Picture space as a vast, flexible fabric. Einstein called it spacetime, a four-dimensional continuum that weaves together everything that exists. This fabric isn't visible, but it's the very foundation of reality. Every event, from a star's explosion to your morning coffee, has coordinates in both space and time. Every moment, every place is stitched into this cosmic tapestry. Place a planet or star on this fabric and it curves. This is gravity. The more massive the object, the deeper the curve, shaping the paths of everything nearby. Gravity isn't a force pulling from afar, it's the shape of space-time itself. Objects move along the curves, following the geometry set by mass and energy. Earth orbits the sun by following the curve the sun creates in space-time. Planets, comets, and even light itself are guided by these invisible contours. We see this in action. Light from distant galaxies bends around massive objects, a phenomenon called gravitational lensing. It's as if space itself is a lens, warping our view of the cosmos. This is visual proof that mass warps reality's fabric. The universe is not rigid, but alive with motion and change. The universe isn't static. Matter and space-time constantly influence each other, shaping and reshaping the cosmic landscape. If space-time can bend, could it break or collapse? What happens when the fabric is pushed to its absolute limits? When enough mass is packed into a tiny area, the curvature becomes extreme, a bottomless pit in reality's fabric where even light cannot escape. This is the essence of cosmic collapse, not emptiness giving way, but the geometry of the universe reaching a breaking point, tearing the very structure of space and time. Understanding spacetime's limits is key to the fate of the cosmos. Only by exploring these boundaries can we hope to unravel the deepest mysteries of existence. To explore cosmic collapse, meet the universe's most extreme characters, singularities and black holes. These are not just objects, they are the ultimate testing grounds for the laws of physics, where the familiar rules of space and time are stretched to their limits. A singularity forms when a massive star collapses to a point of infinite density, where physics as we know it breaks down. In these moments, the very fabric of reality is twisted, and our current understanding of the universe is pushed to its breaking point. Black holes, with singularity scientists once expected, dark energy now dominates, making up about 70% of the universe. Its true nature remains one of the greatest mysteries in science, hinting at new physics yet to be discovered. The cosmos is a tug-of-war. Gravity, from matter and dark matter, pulls together, while dark energy pushes apart. This cosmic contest will determine the ultimate fate of everything we know. The universe's fate, endless expansion, collapse, or something else, depends on this balance. Will gravity pull everything back, or will dark energy drive us apart forever? Our existence hangs in this delicate cosmic equilibrium. Every star, planet, and galaxy is caught in this grand struggle. The outcome of this battle will write the universe's final chapter. The story is still unfolding, and its ending remains unwritten, and we're right in the middle of it, witnesses to the greatest cosmic drama of all time. The universe's fate is a contest between gravity and dark energy. Gravity, the force we know best, built stars, galaxies, and clusters from primordial gas after the Big Bang. Without gravity, the universe would be a featureless soup. Most of gravity's strength comes from dark matter, an invisible substance that holds galaxies together. Together, ordinary and dark matter work to slow cosmic expansion. On the other side is dark energy, a property of space itself. As the universe expands, more space means more dark energy, accelerating expansion in a runaway effect. Dark energy is currently winning, driving galaxies apart faster and faster. The balance is delicate. If dark energy were stronger, the universe would be empty. If gravity dominated, it would have collapsed early. We live in a universe where these forces are balanced just right for complexity in life. This cosmic equilibrium is rare and possibly temporary. The future depends on which force ultimately prevails. The stakes couldn't be higher. The universe began 13.8 billion years ago with the Big Bang. For decades, scientists wondered if gravity would eventually halt expansion and trigger a big crunch, a collapse back to a hot, dense state. The discovery of dark energy changed everything, making a big crunch seem unlikely. If dark energy remains constant, the universe faces a big freeze, endless expansion, galaxies drifting apart, and a cold, dark future. But what if dark energy changes over time? If it weakens or turns attractive, expansion can halt and reverse, reviving the big crunch scenario. When could this happen? We don't know. Current data shows no sign of dark energy fading. If collapse is in our future, it's tens of billions of years away. This isn't imminent, but the possibility is profound. Our current era may be just one phase in a much longer cosmic story. The final chapter depends on the true nature of dark energy. Imagine a future where dark energy fades and gravity takes over. The universe's expansion slows, stops, and reverses. Turnaround. Galaxies rush toward each other. The big crunch begins. The cosmic microwave background heats up, and the night sky glows brighter and hotter. As the universe contracts, galaxies merge, stars collide, and the background temperature soars. Stars can't cool down, they vaporize into a uniform plasma. In the final moments, the universe becomes an unimaginably hot, dense soup of matter and energy. The fundamental forces merge. Space and time dissolve into quantum foam. All of cosmic history, every star, planet, and life form, compresses into a single infinitesimal point. The universe returns to a singularity, echoing its own beginning. This is the ultimate reversal creation in reverse. The end mirrors the beginning, with everything compressed into one final moment. The cycle may be complete, or ready to begin again. In a collapsing universe, the consequences for matter, energy, and reality are absolute. The sky brightens as the cosmic background heats up. No darkness, no escape. Rising temperatures strip atoms apart, vaporize planets, and dissolve stars into plasma. All complex structures are dismantled by relentless heat. As collapse accelerates, even the laws of physics may change. Spacetime warps so extremely that distance and time lose meaning. In the final instant, quantum uncertainty dominates, reality itself dissolves. Life, which needs stable gradients, becomes impossible as temperature equalizes everywhere. All information and memory are erased, returning to primordial chaos. The Big Crunch's symmetry suggests a cyclical universe. Some theories propose a Big Bounce collapse triggers a new Big Bang, birthing a new universe. Each cycle could have different physical laws, leading to new cosmic outcomes. This idea transforms the end into a rebirth, a link in an endless chain. But there are challenges. Entropy should increase with each cycle, making true eternity unlikely. If cycles get longer, there must have been a first, a beginning. Whether our universe ends once or cycles forever remains unknown. The answer lies in the nature of dark energy and the physics of singularity. By studying cosmic expansion, we search for clues to our ultimate fate. The cosmos may still have surprises in store. Our journey to the edge of cosmic collapse reveals profound mysteries. The universe's fate depends on dark energy and dark matter, forces we barely understand. Contemplating the end teaches humility and appreciation for the delicate balance that makes our world possible. The quest to understand these mysteries drives science forward. What is dark energy? What is dark matter? What happens at a singularity? New theories and discoveries may revolutionize our understanding. The idea of space collapsing is unsettling, but it inspires wonder and curiosity. The universe's story isn't finished. We just have to keep listening.